Okay, welcome back. We have our next speaker and next talk ready to go. We'll be talking about JsTestDriver, and our presenter is going to be Jeremie Lenfant Engelmann. Please enjoy the talk.
Okay, don't upload yet. So hi, I'm Jeremie, and I'm going to talk about JsTestDriver. And our goal with JsTestDriver is a JavaScript test runner. And our goal was to make JavaScript unit easy and efficient, because we feel that it's not the case today. Why did we write JsTestDriver? Well, we felt that the existing JavaScript framework are fairly clumsy. First, it's like you have to go on the browser, you have to go on that URL and refresh every time you want to run your test. Also, the test results are displayed on that same page, so you can't really access them from anywhere. And that feels weird to have to go. I'm in my IDE, I'm writing some code, enjoying it, having fun, I'm in the zone, and then I have to go on my browser and hit refresh and wait a few seconds. And that kind of takes you out of the flow. Also, today, Ajax application, I mean, it's a lot of JavaScript. And the code looks more and more like, I mean, I want to say almost like Java code, right? I mean, we have my classes, I'm writing good code, like I need to test it well. And why don't I write my test the same way as I write my code? And then today, the weird thing is that you have that HTML harness that you always need to put in place. And what you end up doing is you find the magic few script tags that you need, maybe some CSS tags too. I think QUnit does that. There's also a CSS to include in your HTML to have nice green and red results when you run. And then you end up copying and pasting that thing to all your files, and then that feels kind of clumsy, that HTML side. Again, the context switching was also a big problem for us. Like, yeah, again, I'm in Eclipse. If I write Java, I can just right-click and run my test. And I have a green or red, and I'm happy, and I know what's going on. Here, again, it's like I'm on my editor, and then, I mean, I know I have, like, virtual desktop, so I will probably go on my second one, refresh, wait a few seconds, and then go back. But that kind of takes me out of the rhythm of, like, coding. And then last point, just to hit the nail on the head, yeah, it's hard. So when everything is in the browser, it's hard to integrate in your IDE workflow, because you need to go to that browser to see the results. Or you need to write some weird script to scrape the HTML in some ways. And then it's like more time than you want to spend on that. So the design principles behind JsTestDriver are these. So first thing is that we want to support TDD development. And what I mean by that is that in TDD, you want to write a lot of small tests, and you want to run them really often. And you want to have hundreds of tests that run in like milliseconds, right? You don't want to have to wait 5 seconds for your test to run. So that was the first thing. It's like we need to be able in JavaScript to do that. Something that's possible with JUnit today and Java again. I guess that was kind of our big model here. It's like the Java experience in JUnit is actually really good when you're in Eclipse. Like, I mean, I love it. And again, and having hundreds of tests running in milliseconds, that's not possible today in your browser. Again, you need to refresh. Maybe the browser will start to cache at some point, some things, but still, I mean, it will be longer than having something that just stream and gives you back the results. It's also, yeah, usually you have multiple HTML pages, so what do? Do you open multiple tabs with each URL and then go refresh each of them individually? I mean, that, again, that feels clumsy. Everything should run the same time. We want it to be super fast, again, because, yeah, we want things to run in the milliseconds range. And what we do here is that we will capture a browser for you, and we will keep it hot. So it will constantly be basically asking for work and do it as fast as it can and stream it back to you. Again, and one thing we do too is that with your HTML page and the JavaScript code today is that you will have to go and hit refresh. But when you hit refresh, actually the browser will probably, I don't know all the optimizations in place, but it's more likely that it will have to reparse the HTML, reevaluate JavaScript, And that's just time that's, I mean, it's lost time. Why do I need to redo that? The page is already there. Everything should be fine. So what we do in JsTestDriver is that we only reevaluate what needs to be reevaluated as far as JavaScript. So if you load like 50 files, but only one of them changes, why reload the 50 files, right? Why reevaluating all that JavaScript? We will reevaluate only what we know has changed. So if there's like 2 or 3 files only that have changed, we will just reevaluate those. We also want it to be really easy to set up. And here, again, with the HTML file and stuff, like usually, yeah, what I ended up doing is like I would copy and paste that big block of script tags and CSS tags or whatever I needed. And that felt clumsy. With no HTML harness and just pure JavaScript, I mean, we just want people to focus on their code, right? We don't want to have them to think about other stuff. So we try to make the setup really easy, and I'm going to show you that a little bit later. Big thing, we want to be really integrated with IDEs. And as I said, we want you to be able to be in Eclipse, right-click, just like JUnit, or click on the green button or whatever, and everything runs. And you don't have to think about it. And to do that, again, we had to extract these results that were prisoner of that HTML page earlier, and then be able to get them and stream them back to you wherever you are. So it could be on the command line or on your IDE or whatever other client you may have. We keep, because we are still using browsers, actually, we can still support the debugger that are in place. The Safari debugger, Firebug, Bankman. Even though Firebug, I just realized since they updated, we have some trouble with them, but that's going to be fixed. We also run your test all in parallel on all the different browsers that you have. So the first phase in JsTestDriver is that usually you capture a set of browsers. And again, if you were to do it manually, you might have to go on each window, hit refresh, gets kind of old. Here we just run everything for you as fast as we can on all the browsers. And again, we're like in the milliseconds range. We also have, we were really focused, oops, I'm sorry. We are really focused on the command line and the continuous build. Like, again, today it's kind of hard if you have a continuous build to make it fail. It's like you might have, again, to scrape some HTML to try to get the result, or there might be maybe some JavaScript object in there. I mean, it's kind of complicated when you have a continuous build to do that. Same thing, the results are on that page. I mean, that's really a problem here. So again, because we're focused on the command line and the continuous build, you can get the results anywhere, and it's easier for you to integrate with your existing tools. One thing that the HTML page did fairly well is actually adding DOM elements. So because, well, it was HTML, so you could just type your script tags, I mean, your tags in there, and they would be available for your test. That's one thing that if we were to write that in pure JavaScript, that would take a few more lines than just writing the tags down. So for that, we actually added some syntactic sugar, and it's basically a magic comment that you can add in your test. And what that will do is that you can just type the HTML as you would do on a web page, on a regular HTML file, and that will include these tags every time your test run. And that will clean at the end of the test and include the new ones if you have new ones. One also great thing that we have is that we actually have code coverage for JavaScript. We are instrumenting the code, and we can provide you with code coverage data. We are using the LCOV format, which is like the generic Unix, Linux one. So you can use all the LCOV tools. Everything should work. So for example, you can generate nice HTML files thanks to that. Now, that's a nice picture. And that's basically the architecture of JsTestDriver. As you can see, there's, well, really 3 parts. The main part is the server. The server is basically just an HTTP server, really. It's kind of smart, but it's an HTTP server. And the way it works is that you will start your JsTestDriver server, and then you will capture a few browsers. So you just go on a magic URL on the JsTestDriver server that will, what we say capture your browser and then make it basically a slave of JsTestDriver. And the work that the browser does from that point on is just connecting to JsTestDriver the server and ask, do I have anything to do? Please give me work. I really want to work. And that's all it does. We have another part, which is the client. And the client can be a command line client, or we also have IDE integrations with Eclipse and IntelliJ. And the client is the one, while giving orders to the server, and says, hey, I need to run my test on all the browsers that you have captured. That command goes to the server. Server puts it in the queue of each browser. Each browser is really eager to run these things, run them, stream back the result to the server, and the server streams back the result to the client. The client is also the one responsible through a config file, is responsible of telling the server what files should be loaded in the browsers. So the full communication between the client and the server is that the client will start by telling the server, hey, server, I have these files. I want you to load them into each browsers. And the server will be, okay, fine, upload them to me. That's happening. Okay, I'm loading it in all the browsers. And then the client can be, okay, now run the test and give me back the results. So that was a lot of slides, and that's all I have. And now that's the interesting part of the demo. So I'm going to show you, I'm going to start with the command line stuff, just to show you the basic principles here. And then I'll demonstrate how we integrate with Eclipse. I'm more of an Eclipse guy. But we also have it for IntelliJ. So first thing, I have my jar, and I need to start the server, as I said. So I'm going to start the server. Is it readable, more or less? Yeah. So it's listening on that port 9876. And the next step is to actually capture the browser. So I'm going on that URL. So my IP, home 9867, and I just capture. And what happens here is that now the browser, that page, is our JsTestDriver slave. And what's happening is that it's sending XML HTTP request to the server asking, give me work. So now I also have code, and I have a few tests. So I started by writing my test, and I knew, like, okay, I need to test that my hello world object does what it should do. So you can see the first line, and that's the setup. You need to create a test case with JsTestDriver. And basically just, you call that method test case, and you're like, I'm going to have a new test case, assign it to a variable. What's returned is not an instance of a class, it's the template of the class. So then on it, you can add your test methods. So here I have a few tests. I have the test hello, creating an object hello world, putting some log just to make sure that everything is fine. And I'm checking that when I call hello, the string hello is returned. Pretty simple. Same thing, I have another test, hello you. I need my hello world object. And I'm just asserting again that when I call hello you with a parameter, it will say hello me with an exclamation point. The last test is interesting, and that's the syntactic sugar I was talking about. So that allows you to add HTML, I mean DOM elements, well, in your DOM. So it's just that magic, I mean that command that's like /star column doc, and from there you can just write HTML like you would write on a regular HTML page. The plus equal just tells JsTestDriver like, hey, you should add these elements to my document. And so then if you see in my test, I can assert that the element with ID foo is actually present, and it's not null. One last piece that you need, so then, I mean, the hello world code is fairly straightforward, right? I have two functions, returning string, and hello you with the string that was passed in. The last piece, and so just disregard the commented part for now, you will see it later, but that's the configuration file I was talking about that the client uses to tell the server, hey, you need these files. You need to load these files in the browser for me to be able to run my test. And all I'm saying there is that I can use some globbed expression to say, hey, I want you to load all the JS files that are in source and all the JS files that are in source test. So here you can see in the tree that I have a source directory with my source files, and I have the source-test directory with my test files. Pretty straightforward. The configuration file has other keywords, like you can exclude if you want some files, if you need to, that you don't want to be loaded, stuff like that. So now to run the test. So I have a jar. Well, disregard the first part, I guess, java-jar and the jar itself. The interesting thing is here is the server. So I'm just telling my client, we have a server running on localhost 9867. You will need to run your test there. And then I have the test flag, and I say, well, I want to run all the tests that I have. So I'm going to press enter. And what happened here is that the client talked to the server, uploaded all the files, and ran, and then everything ran. As you can see, the output is pretty straightforward. Dot is success, F is failure. If I had an error, there would be an E. It ran pretty fast, if you've noticed, compared to going on a web browser and hit refresh. And here I can see, well, I have 2 tests that passed, and I have 1 that failed. And I'm like, what did I do wrong? So you can also see that I added some log in one of my tests. We can see it right there. It's also streamed back from the browser. So I know that it was in test hello. I had some log that say, hey, some log just to try. It looked like it tried really well because it worked. And test hello, you failed. And I have what happened is like I was expecting hello me, but I had hello me. So instead of an exclamation point, I had a dot in the end. And I know that it's hello world test line 15 where I had the problem. So I can go check my test and be like, okay, so I was calling assert equals hello me. Yeah, indeed, I want an exclamation point. I call hello you with me, but it didn't return what I expected. It's like, oh, okay, well, yeah, silly me. I needed an exclamation point here instead of a dot. And so let's rerun now. And so we rerun again really fast. And now everything passes. And I'm happy. And I can go on with my day. So that's the thing. And here you can be like, and you can say, hey, but you said like going to the browser is really annoying. So why do you go to the command line? It's like, you're right. We shouldn't do that. And so we worked on, oops, I killed Eclipse. We worked on IDE plugins. So as I said, we have a plugin for Eclipse, and we have a plugin for IntelliJ too. IntelliJ version 7 and 8. I think there was some difference there, but so we have it for 7 and 8. So in Eclipse, we have so that plugin. So it kind of looks like JUnit. We tried to make it look like JUnit. But there's a little bit more buttons, and maybe just to start, a little more steps involved. But that's actually really, really straightforward. So let me just shut down this server for now, so I can show you everything. So here you can see not running. That's that little box that says not running. That's actually the server, and that's the status of the server. And so while we probably want to start the server. So now it's yellow, which means server is running, but no browsers are captured. And it just gives you the URL you need to use to capture your browser. So you can copy and paste wherever you want. But we also have some nice little buttons here, and we can click on them to capture some of the browsers. So I'm on a Mac, so I'm going to go with Firefox. So let's open the browser, it's captured. You can see now the Firefox icon is nicely lit. And because I'm on a Mac, I also have Safari, so let's also capture Safari for my run. Let's say I never saw the bug earlier, so I didn't correct it. And now all I need to do is actually, well, just like I would do with JUnit most probably, it's like I'm just going to right-click, run as, JsTestDriver test, and that run. Again, really fast, just like JUnit. It's red, something is wrong, what happened? You have the same output that you would get from the command line. So we are streaming it back. Interesting thing to notice, right now, Firefox gives us a little bit more detail. We can get stack traces. We can't get them in Safari and in IE. The thing is that we are thinking of making that possible thanks to the actually reusing some of the coverage code that we have to be able to actually generate stack traces for any of the browsers. That's a little bit in the future. But again, so just like JUnit, I have the same icons. I can see that the test LOU failed. Was expecting hello me, but it was with an exclamation point, but there I had a dot. I can change it, save, and rerun, and now everything is ready. So here, that's really the experience we want people to have when they write JavaScript today. Again, because the apps become more and more complex, and they become really big apps in JavaScript, like the tool should be as good as what we have for Java, for example. Now I'm going to show you something else, and I'm going to show you the coverage, actually. So it's really interesting to get coverage data for your project, just to know where you stand, and if, I mean, just to check the health of your project. So we are, as I said earlier, we are instrumenting the code, and we can get you the coverage from that. So what I need to do here, I think I have some correct in there. Let me just, so you can see that the files were already created. Okay, there we go. There you go. So you will see all the files appear. So you can see, so I'm going to run the client. So the server is still running on Safari and Firefox, and you can see that by the green bar. If the server was down, actually the bar would turn red to let you know, like, hey, the server is not there. You need to restart it. And what I'm going to do, actually, the first step is I can reset the browsers just to make sure that the state is what I want. And then I'm going to run the coverage. So what I'm doing here is that I add a flag to actually create files locally to create the lcov file. You can also run the coverage without creating that lcov file. If you do not do that, the results of the coverage will appear on the command line once the process is done. What I want to show you here is that to use the coverage, you actually need to install a plugin. And that's the coverage plugin. That's also set up in the configuration file. We have plugin systems on both sides if you are interested in extending JsTestDriver. So we have Java code and we have JavaScript code. And yeah, we have plugin system on both sides. So you can extend the JavaScript if you need to run maybe more specific tests, or you can run, I mean, you can write some Java plugin to do more stuff. So here I'm just going to basically uncomment that part. That's just standard YAML format too. We've used YAML. And here I'm just saying, okay, I need the plugin, and the name is coverage, I'm sorry. And the jar is where I'm telling you it is, and the class, that's the setup class basically, is named coverage module in that jar. So yeah, I'm going to rerun the test, but this time with coverage. Oops. Am I missing a test? Yes, thank you. I have only one. So as you can see, there's a little bit more output, and that's JsTestDriver instrumenting the code. We're also not putting as much detail maybe in the final summary here, because again, we've generated files. So the test output flag made it generating files. So here you can see I have some XML files. That's basically standard like JUnit XML files, so you can use them with your continuous build if you need to. And I have that new file that's JsTestDriver.conf-coverage dat. And that's basically my lcov file. The lcov format, what is kind of weird, but that's what it looks like. And the good thing is that because we're using Elcove, we can use the tools that already exist for you to generate maybe the reports and stuff. So here I'm just going to use the standard, like coming in the Elcove package, the gen HTML, and just feed it my file. And that created an HTML report for me. I can show you here. That's why I removed all the files originally, just to make sure that the new ones were there, and you could see it's real. And I can then, from there, I can well open the index.html, and I have my coverage data. The coverage data is basically the coverage for all the browsers that run here. So I know that, for example, return hello was run 4 times, executed 4 times, because, well, both of my tests, the first one calls hello directly, the second one indirectly by coding hello you calls hello. So yeah, hello was actually called 4 times. You can obviously not, you can capture only one browser to get this information only on the browser you want. But basically here, so you have all the data for all the browsers. And we're really happy with that too, because, well, again, I know one tool to do coverage in JavaScript, and I think most of the JavaScript framework really don't do that really well. So yeah, and again, because we are using Elcove, you can use all the existing tools for Elcove today. One last thing I can show you quickly is what I was saying. We are supporting debuggers in the browser, so I'm just going to demonstrate that pretty quickly. Just so we want you to be able to debug just like you would, because it's great to stay in the IDE, and what we really want you to do actually is just like, yeah, I mean, what I like to do is that I like to write tests and write my code then, and when I change something, I want to run my test really, really often. Like, I'm changing a line, I'm going to run my test and make sure that it's still green. And if it's not green, it's really easy for me to know what's wrong, right? Because it's like, well, I've just wrote one line, so I know what's broken here, and I can take care of it. But there's sometimes where you might need to actually go into the browser and actually start to debug, put breakpoints and stuff like that. So I'm going to show you that you can put a breakpoint, and that will actually work the way it's intended. So I'm just going to reset again, because when we instrument the code, well, because we're instrumenting the code, we're adding our own JavaScript in your JavaScript to get the coverage data. I'm just cleaning that up right now. Also going to start the Safari debugger. Okay, enable debugging. Let me find, so we can see that the tests continue to run properly. They run on Safari and Firefox. And yeah, I can find one of my files. So let's say, let's put a breakpoint in hello, and let's make sure that it actually will block when I run. So same thing, I'm just running the client the good old way. Oh, it's blocking. Oh, it's in the breakpoint. Cool. Let me just finish that and finish the run. There you go. And it finished. Oh, yeah. There's one thing to the way we need to know if the browsers are dead, because we want to be really good with a continuous build. There is actually a flag I need to add. We were kind of strict on when a browser is dead, and some of the debuggers, so we have actually frames, and some of the debuggers sometimes block both JavaScript frames, so we kind of, we think one of the browsers is dead, so that's what happened here. But yeah, that will be a flag that you can switch on or off when you really want to debug long sessions. I need to add that, it's not in there yet. That's it for my demo, and actually that's it for the presentation too. Thank you for listening. Do you have any questions?
Thanks very much for the presentation.
Thank you.
I'm curious about your coverage data.
Yes.
If I picked up correctly, you're instrumenting the JavaScript code to get
Yes.
that. Is that right? I mean, obviously that's a portable solution, but it's sort of fraught with danger. Is there any way to get inside any of the JavaScript engines to collect that data as the JavaScript's running without having to mess about with the code?
So we like actually the JavaScript approach because, as you said, it's portable and it can work anywhere. We don't really have any plans to try to get into the JavaScript engine, and I think that's going to stay that way unless we really have extremely compelling cases showing us that we really need to be there. But right now, we feel that that's working well, and that's, again, that can work anywhere. And so we're fairly happy with that. We don't want to have to also maintain different plugins for different browsers if we can avoid to do that. It's already a moving target. I mean, as you saw with maybe some of the debuggers and stuff to maybe sometimes keep working with them. So we don't want to add more code to that again. And again, yeah, that's the most portable solution, and it's working really well so far. So we haven't seen any case where it would be required to have a plugin. Great.
I have a question about integration with the continuous integration server.
Yes.
Like the great thing about Selenium is it coordinates the browsers really well, starts them up, shuts them down, and so on. How do you manage that?
So on the continuous build, actually, there is some more flags to JsTestDriver where you can specify. We have a mode. We used to call it Skynet mode, but it's not the case anymore. And that mode is basically JsTestDriver is doing itself everything. So it will start the server, and you can specify on a flag like where your browser's executables are. So it will start the server, start the browsers, capture the browsers, run all your tests, and shut down everything. So that's how you would use it in a continuous environment. Actually, I can show you. We are using it ourselves for our own test. Somebody is committing to JsTestDriver. Awesome. So let me get some. So here, if you see the graph, actually, so that's Hudson. That's what we use for the continuous build. But just to show you these big peaks, that's actually all our tests, Java and JavaScript. So everything is integrated in Hudson. That's why we are creating this XML file I showed you also quickly earlier, the JUnit type 1, because we want to have that data on the continuous build when we write our own code. Let me show you just one quick example of the results, just to show you that it's there. So that's all our tests here that run for the continuous build, our JavaScript test cases. So you see we have assert plugin test. Let's go in there. And then I can see for each browser what the time was and if it passed or not, right? So I have everything in the continuous build environment. That was really one of our focus. On the other hand, right now, maybe the way we are starting browser is not as fancy as Selenium or WebDriver, probably. And we're thinking of actually maybe checking with WebDriver and maybe reusing some of their code for starting browsers. Yes? You're all for it? Awesome. I like that. So we need to be in touch for that. Just so you could, because here it's like you have to, on the command line, you have to specify the executable path. Not everything might be set up correctly. So that's why we want to go the WebDriver route. Question?
Yes. First, is it possible to put the browsers in the other machines? Say we have several machines to have different browsers and run the test at the same time so that all the test can be executed in all the browsers at the same time?
Yes, it's possible. I mean, it's just an HTTP server, so basically you can connect from anywhere, right? I mean, as long as you have the IP, I guess. But you can have, I could have a Windows machine connecting right now to my server and running test. Again, we kept it really simple, and then that architecture of client server browser allow us to do that. So you could have browsers anywhere on any machine. You just need to connect on the server and everything will run. And again, it's I mean, as you saw, I mean, here too, again, we are, even that way, we are really fast, like it's in milliseconds range. And we were really trying to keep it out that way.
I think you just answered his question.
Cool.
What happens to tests that interact with the browser themselves, such as navigating from one domain to another? Do you have a security problem there?
Yes, so that's the funny part. If you change the URL, you will break us. Because our runner is basically, yeah, it's a lot of JavaScript connecting to the server. We are trying to prevent people from doing something. For example, we prevent people from doing document.writes too, because they could just destroy the document and lose all our code. So there is certain things that you can't do. But that's also on purpose. That's because we want to really focus on unit test and not on end-to-end test. I guess here WebDriver would probably be a best solution if you want an end-to-end test. We really want to be like the unit test, just like JUnit is, and then we want to test the logic and stuff like that. We don't want to be in the business of end-to-end test.
Thanks.
All right.
So to expand on what he said,
yes.
Theoretically you could point the BlackBerry browser at.
Yes, I've never tested
if it was supported.
Yeah, I should
iPhone.
test. I don't have a BlackBerry, but I should test with it.
But iPhone or Android?
Yeah. Theoretically, you can point anything. The only thing is that, yeah, I have to, I've never actually tested with mobile devices. I should start doing that. But yeah, I don't see why. I mean, if it can run JavaScript, it should be able to run it.
Very cool. Okay, so I got a couple things. The HTML magic comments in there.
Yes.
Is that just an alternative to DOM manipulation if you need to
Yes,
work
it is.
with things
I mean,
on the page?
you can still write JavaScript if you're more comfortable with, you know, doing create element or whatever. It just, we felt, yeah, one of the only thing that the HTML5 did right was like, yeah, I can just write my HTML tags, you know, and then I will be able to access them from my test. And we felt that in JavaScript, it just takes more lines to say the same thing. Like you need to create the element, append the child. You might have multiple elements. I mean, that becomes quickly kind of annoying. So that's really syntactic sugar.
Okay. The stack traces you have now, is there some plan to make those clickable so you can go right to the line?
Yes, it is in the plan.
Okay. The coverage, can that be imported into Eclipse and displayed with the file?
We would love to do that. We have to check actually. So that's also why we went with the LCOV format. We were hoping that we could reuse a lot of things that were existing. Actually, I'm not the one working on the IDE plugins. It's another person working with me. But I think, yeah, he's going to look into it. We hope that with the LCOV format, it will actually just be us coding existing libraries in Eclipse for us to be able to display most of it. Okay. So it shouldn't be too hard.
In terms of the debugger,
yes.
Do you have any conceivable way to integrate that more into the IDE so you can set breakpoints and have the browser launched on failure? Or?
So that's really something we want to go to. We would love to have everything integrated in the IDE. Again, that's in the works. It's not there yet. It's going to take a little bit of time, but that's definitely our end goal really is to be like, yeah, what JUnit and Java are on Eclipse. We want the same for JavaScript.
Well, it's tremendously exciting stuff. So thank you very much.
Well, thank you.
Hello. Does JsTestDriver support different unit testing frameworks, such as QUnit, UI test, and etc.?
Yes. So as I said, we have plugin systems on both sides, so on the JavaScript side and on the Java side. We actually do support QUnit, and that's actually someone on the open source community who wrote the plugin for it. It's working well. We were really trying to encourage people actually to write their own plugins if they want to support existing frameworks.
Is there an adapter for the JsTestDriver reporter or something like that?
Yeah, so the QUnit plugin, I haven't looked at it into details, but basically all you need to do with the QUnit plugin is adding it to your configuration file. That will load the file just like any other file, but that will patch some of our code. And from there to the user, that just looks like any other JsTestDriver test. So you get exactly the same feedback on the command line that you would do with any other JsTestDriver test. And that's, I mean, so yeah, we are really encouraging actually people to, if they have favorite frameworks they want to work on and they want it to work on JsTestDriver, we encourage that, and we really want people to do that. We're actually, we're trying to be more of a kind of a standard runner in some ways, and that's why we really want people, if you love QUnit, you should be able to use it with us. But it should feel as good as what JsTestDriver feels like, right?
If we have no other questions, we kind of resume here in about 15 minutes, but you have 15 minutes to grab a cup of tea, coffee, or visit the restaurants. Thank you a lot, Jeremie.
Thanks a lot, everyone.